So our speaker today is Horia Purushu. He is one of our blockchain experts on the dev advocacy team, and I've had the pleasure of doing many webcasts with him in the past. He's a very prolific speaker on the conference circuit around blockchain, and I've seen him lead workshops on blockchain as well. So he knows this Hyperledger stuff front and back, and I'm anxious for him to share that knowledge with you in the context of supply chain transparency today. So Horia, welcome to IBM Developer Tech Talks. What do you got for us today?
Yeah, thanks, Calvin. So just I wanted to give a brief intro for myself. My name is Horia Purushu, and I've been working here at IBM for the developer advocate team and focusing mainly on blockchain. And of course, I'm really excited for today because this is kind of one of my favorite topics to talk about, which is supply chain management. And I see this as one of the most prevalent and kind of the lowest hanging fruit in terms of blockchain. So I'm excited to talk to you about that today. And today I'll be talking about one of the projects that I've worked on that is dealing with a coffee roaster. And that's kind of in the realm of supply chain management. So I want to show you this real world use case and how it can be applied in with blockchain as well.
And Horia, just to emphasize that a bit, I mean, you actually did this project with an actual coffee bean company, right?
That's right. Yeah. So yeah, we took some of the supply chain documents from the roaster, and they were gracious enough to give us their documents and work with us and really help us create something real out of these out of their documents. So this is pretty awesome. Exciting stuff.
Yeah.
So I'll go ahead and start sharing my screen here. We'll go into a little bit of background on Hyperledger Fabric, and then I'll go into the demo and I'll talk a little bit about other blockchain use cases outside of supply chain too, although I'll still focus mostly on supply chain. So let me go ahead and start sharing my screen here. Okay. Awesome. So you should be able to see my slideshow now. So I'm about to start. So again, this is going to be using blockchain to increase supply chain transparency. And if you want to follow my Twitter, I have some of these. I have more blockchain tutorials on there, and I'll have my slide pin on Twitter if you need those as well. And you can just find my handle at the bottom left corner. So at Horia Purushu. And again, for my slides, you'll be able to find them on SlideShare. And for the agenda today, I just want to talk a little bit about Hyperledger Fabric, and then I'll go a little bit about kind of the differences between Hyperledger and Ethereum, which is there's some subtle differences there. They're still using the main blockchain concepts such as cryptography, and they're still both very much focused on transactions, but I want to get a little bit into the details about the differences between Hyperledger and Ethereum and what makes Hyperledger attractive to the enterprise. And then I want to talk a little bit more about the actors in a Hyperledger Fabric network, and I'll go a little bit more into the consensus and the endorsement policy. And then I'll end with the blockchain bean demo. So at this point, you might be feeling just like Michael Scott here, saying like, okay, I understand nothing about blockchain. And hopefully by the end of the talk, you'll feel a lot better and understand at least some of the main key points. So what is Hyperledger Fabric? So in terms of blockchain, Hyperledger Fabric is an open source platform, and it's used for smart contract development, and it's aimed at the enterprise. And this platform is becoming very popular, and there's a lot of other Hyperledger platforms out there or Hyperledger projects out there as well. And there's about 9 or 10 of them right now, but Fabric is the main one that has gained the most popularity and the most traction so far. And this is important because it's hosted by the Linux Foundation, which is great for fostering open source projects. And they have many other projects they host, such as node.js and Docker. And one of the major differences that I want to touch upon in this presentation is the main is that there is no concept of mining blocks. So in Ethereum, that's one of the main ways that consensus happens on the network, is that miners are proving that these blocks are correct and that they're proving the authenticity of the transactions. And this does not happen in Hyperledger. That's one of the main key differences that I want to touch upon. And another one of those key differences is that Hyperledger is a permission blockchain. So you need to be invited and you need to be able to accept this invitation to the network. And some of the open platform or open networks that are out there right now is one that is gaining in popularity is the IBM Food Trust Network. And that's started by Walmart. And that, again, is an example of this Hyperledger Fabric network that's in production right now. And that is open to be able to join. So you'll be able to request access, and for some sort of monthly fee, you'll be able to join that network as well. Awesome. So let's go ahead and talk a little bit about the throughput here. One of the main differences between having Hyperledger Fabric and sort of a more cryptocurrency-focused platform like Ethereum is the transaction speed, or the throughput. And that's a big reason for that, is that Ethereum does need to do mining. So it is going to be a bit slower. And that is one of the main differences between Fabric and Ethereum, is this throughput. So you can see here, these are some approximate measures. And Hyperledger Fabric has about around 500,000 transactions per minute, whereas Ethereum has around 1,000. So this is going to be a lot better for efficiency in terms of this platform. And again, it is a little bit different. So Ethereum, anybody can join the network, whereas Fabric, for this reason, for being more efficient and for taking out the miners out of the equation, we have a network what is not fully open. You have to gain access to it. And this was made on purpose. So we've seen this need of increasing throughput, and Ethereum is working on this right now. I believe that they're releasing some update within the next couple of weeks that is increasing their throughput, but still, it's nowhere near this Hyperledger Fabric throughput. And another big question that I often get when I do these talks is, how is this different than a central database? So this, the way that Hyperledger Fabric works is that you can think of it kind of like a distributed database, but it's backed by cryptography, which is one of these main key aspects. And of course, the more peers that you have in a network, the more distributed this data is going to be, because each peer has their own database attached to it. So usually in a big network like IBM Food Trust, there's going to be thousands or hundreds of thousands of peers. So there's going to be a lot of different points of failure, which is a big reason why people, or why the industry is interested in blockchain in general. So essentially, if you are updating the state of the ledger in Fabric, and if you make a mistake, you'll need to have another transaction to fix it, because once this transaction goes through the consensus policy and the consensus says that this is correct, there's no way to fix it other than by making another update to the ledger. And we'll talk a little bit more about the consensus policy as we go on in the presentation.
Hurry, but isn't that the strength of the Hyperledger, that it becomes an authoritative source of truth and that nobody can just change willy-nilly?
Exactly. That's one of the main points why this system is so has gained so much traction, I think. And it's that there is no way to change something in the data without someone being able to see that and be able to track all those steps of what exactly has been changed. So you're right, that makes it that actually makes it a little bit more attractive, in that there's no way to really alter the data, and there's no way to go back and tamper with the data.
Thanks.
So, of course, we kind of covered this this point, but yeah, there's no delete operation. And so if you start from the Genesis block, which is that first block that the blockchain starts with, and you go through all of the blocks and you replay all of those transactions, that's where you get to the current state of the ledger. So this current state, you can think of that as the truth. That is what is currently in the database, and that is what all of the peers on the network have agreed to is the truth. So again, if you make a mistake in that current state of truth, you'll have to send another transaction to update that state of truth, and only if all the peers agree and the consensus is reached, only then you'll be able to change that current state or that state of truth. And a big part of this innovation, which I really like to understand as, so when I think of blockchain, I think of it as the intersection of networking, of cryptography, and of databases. So this is that key aspect here is cryptography that is kind of different than what we have just in the generic central database, in that every single time we send a transaction on the network, it's cryptographically signed so that we can see which member on the network or who on the network is actually initiating this transaction. So that's really important because only certain members will have access to certain parts of the network. And one of the key processes is to actually check, does this member have access to this function on the network? And the way to do that is to see, which signature was written with this transaction. Another important thing is that Hyperledger Fabric is they have very flexible requirements on hardware, on network infrastructure, on software and security. It's made so that you can customize it to your use case. So that's been a really awesome part of Fabric, is that they made it very tailored for many different industries on many different hardware, and that's a great aspect of it as well. So one of the main, also another big thing that we need to mention is that the Fabric is not vulnerable to the 51% attack due to the fact that the consensus algorithm is different. So in proof of work, which Ethereum and Bitcoin both are using, there's a concept that when there's a tie, or that there's two altering versions of the truth, which is kind of called a fork, they're going to go with the one that has more computation and which results in a greater proof of work. So one way to kind of cheat the system in Bitcoin and Ethereum is to try to gain access to 51% of the computation or the compute resources. And that is what is called the 51% of attack, in that if you control 51% of the resources, you'll prove to the network that you have a bigger proof of work, and the consensus algorithm will pick your fork because you have a greater proof of work. That's how the algorithm was set up. So that's another interesting bit that makes Hyperledger Fabric a little bit different. And one of the main, so now I want to talk a little bit more about the industry use cases. And one of the main use cases that I see is that when you're doing business with a party that, you know this party, but you don't necessarily trust everything about them. And at a certain point, when I think blockchain is really the most interesting and the most useful, is that at some point you get a disagreement between party A and party B. So this could be a company, this could be two people, this could be any two entities. So at some point you get in a disagreement and your records don't match. So this is the point where I think blockchain becomes really useful. Right. And at the current state, we have some sort of settlement process. So we can go ahead and get lawyers involved, we can do audits, or we can hire a third-party authority to kind of check all of our documents. But this is really expensive and it's very time-intensive. And this isn't really the most efficient way to solve something, especially if you don't have the money to pay all these lawyers and the time to do these expensive audits. And again, I've talked about using a third party, so you can rely on a third party, but of course you have to pay them as well to verify your data, and also all of the other company that you're doing business with has to trust this third party as well. They need to use another third party authority as well, because if they don't trust the party, if they don't trust this verification, then this makes no sense and it doesn't really work. So of course this is difficult as well. So Another key thing is that the verification party is run by humans, and of course that's prone to mistakes as well. And this is kind of the main problem I see right now. And there's no way to work with these two parties efficiently that don't trust each other. And this is where I really see Hyperledger Fabric and blockchain in general being able to solve this key problem, is by programming smart contracts to be able to run these transactions through, and only if the smart contracts accept the transactions, only then will the transactions be put on the network. And the important part is that there's no way for any party to alter the data. As we talked about before, you can only update the ledger. So you can think of it as something like a linked list, where every new node is going to be a new update to the database and a new update to the state of the ledger. So you'll be able to go back in time and see all those updates one by one, so that if you want to go back and audit, it's very easy, and it's very everything's out there for anyone to see. So at this point, I want to make a quick comparison. So there's three main actors in Hyperledger that I want to talk about, and one of them is the peer node. So I've talked a little bit about these before, but the peer node is really the main actor in Hyperledger. So if anybody here has seen The Office, then you can kind of compare Michael Scott, or the manager in The Office, to the peer node. So without Michael Scott, there would be no Office. He's the manager, and he's kind of running the show. And you can think about the peer node in a similar way, in that the peer is running the chain code, is really running the smart contracts on the blockchain. So without the peer, there would be no smart contracts, and that's one of the key points why developers want to use a blockchain network, is to be able to program these this logic into the transactions. Secondly, the cryptographic aspect comes from the certificate authority. And in an office setting, you can think of this as the head of HR. So if you've watched The Office, you'd know that Toby Flenderson is the head of HR in The Office, and he's the one that will hand out offer letters. So saying this is you're going to be working for this many hours a week at this dollar amount per hour. We verified your previous work experiences, we verified your degree from your university, and we're handing out you this offer letter that says that you're going to be working at our company. So similarly, on a blockchain network, the certificate authority will hand out certificates, which come in a public-private care key pair. My bad.
Key pair.
Yeah. So that's your kind of your offer letter, or your invitation to the network, is this private and public key. So, and every time you do a transaction on the network, anytime you want to interact with the network, you'll have to show that, or you'll have to sign your transaction with your private key. And then that will be able to prove to others on the network that you're allowed to make that transaction. And the last main actor in Hyperledger that I want to talk about is the order. And this is the one that is broadcasting messages to the peers. And at the order, what they really do is they take these different transactions. So you'll know that there's different peers that are executing different transactions at the same time. And the orderer will listen to all of the transactions, and it will chronologically sync them, and then cut out these blocks, and then send it back to the peers. And after that, once the peers get the blocks from the orderers, they'll make a quick check that everything looks okay. And then if everything looks okay, they append that block to the ledger, and that eventually changes the truth of the ledger, or updates the ledger. And in the office, that would be like Pam. So that would be like the receptionist in the office. And when someone wants to talk to Michael, they'll go through Pam and say, hey, I have an appointment with Michael. I'm supposed to speak with him in an hour. And Pam will say, okay, sit down, please. I'll go ahead and tell Michael to expect you, or to, that you're coming in. So you can kind of think of the receptionist at the office as an orderer, as in they're broadcasting messages to the different employees. And now, before I want to get into the supply chain demo, one last thing I want to cover is the endorsement policy. And I do want to cover all these aspects as I'm showing you the demo as well. So I just want to kind of go through these key concepts, and then I'll kind of point them out in the demo as well. So again, we talked a little bit about how cryptocurrency uses this proof of work consensus policy, which does use miners, and it has been critiqued that it's very energy inefficient. So the endorsement policy is a little bit different in Fabric, and that stems from the reason that it's a permission network. So of course, in a permission network, you have to gain access to the network, and someone has to approve you. So you are going to know who you're working with. You're going to know the different parties, and that makes it a little bit easier to reach consensus if you know all of the parties in the network. So what you can do really, and what is beautiful about Hyperledger Fabric, is that you can actually create your own consensus mechanism, and you can say which peers in the network and which organizations in the network need to verify and endorse the transactions before we update the ledger. So maybe if you're just testing out your network, you can say, okay, only one peer needs to verify the transaction is working, and then we'll update the ledger. But in a more production environment where you want to, where you're really focused on data integrity and really high security, you will want to make sure that almost 100% of the peers are in agreement or have verified the transaction, or at least one peer from each organization has verified this transaction before you update the ledger. But again, this is up to the developer, and it's up to who designed the network to create this endorsement policy.
Yeah, that's something I think that's one of the things that impressed me the most when I started learning about Hyperledger, is that you can design the consensus policy as a reflection of the nature of the business that you're trying to conduct on the ledger. So like if you're running car registrations and license plate issuance, on a Hyperledger, it might be that it's the DMV offices are the ones that can verify a transaction, and not just anybody. And so I think that's one of the things that has really struck me, is that in the Bitcoin Ethereum world, there's basically one type of consensus that everybody has to figure out how to use. Whereas in the Hyperledger world, you can design your consensus as the needs of the business require. I think that's something that really bears repeating. I don't hear people talking about that nearly enough.
Yeah, exactly. And I think that's one of the points that we've seen. That's one of the points of failure. I think that, not failure, but I don't want to say a flaw, but that's something that has bothered people, is this consensus policy in Bitcoin and Ethereum. And you can see I know that Ethereum is looking to change that, and they're looking to go to the proof of stake consensus policy. But you can see here that still it's hard to have it right with one consensus policy, because each use case is so different that you'll need something very flexible and something that can adapt to the business. So that is something really important that was designed very well, I think, from Hyperledger. So as we've talked a little bit about, with some examples are that only one peer can verify the transaction, which I said earlier, that's probably only good for testing purposes. But of course, you can have all the peers. That will take a little bit. Of course, that will slow down the throughput, so the transactions won't actually happen as fast if you have all of the peers verifying the transactions. So you have to keep that in mind when you're designing your network. Is do you want throughput to be the number one priority? If so, then we might have to change the consensus policy to have only half of the peers, or one peer from each organization validate the transactions. If you want to have integrity in your data, or more secure data, but you're okay with having a slower transaction rate, then you'll be okay with creating this endorsement policy that has all of the peers verifying the transactions. So again, you have to kind of design it the way that will be best for your use case. So now there's also more complicated things, which I'm gonna skip over for now for the sake of time. But you just want to kind of throw this point out in that if you have you can have multiple smart contracts running within a network, and each smart contract can have a different policy. So I don't want to get too deep in those details, but just know that it can get much more complex once you're deploying multiple smart contracts. So now I want to talk about two approaches, and then we'll jump into the demo. So what you can do right now, if you want to get into Hyperledger, is that there's a free open source version that you could run on your local computer, and that will show you how to run Docker containers, which will spin up the peer, the orderer, and the certificate authority, those three main actors that we talked about, and then also the CouchDB, which is where all the data is held, and that's what is the state of the ledger on the peer. And the one downside to working locally is that inviting other organizations is harder, and to view all the transaction details it takes a little bit more time, and you have to be really good with Docker and kind of inspecting all the different details of the containers. So what I want to show you a little bit today is I want to show you the IBM Blockchain Platform Starter Kit, which is really great, great way to show you a nice UI over Hyperledger Fabric and have a really easy way to set up your network and to view the transaction details. So it has a nice interface, and it's really easy to invite other organizations to the network. So with a click of a button, you can invite other organizations and to expand and scale your network really quickly. Otherwise, in Hyperledger Fabric, you'd have to work with all the APIs and programmatically do it on the open source version.
Hey, Huria, let me just jump in and inject a commercial briefly.
Sure.
So as I mentioned at the beginning, below the YouTube player, the first link in the description will take you to today's event page. And on that event page, we have a link to the blockchain landing page where you can sign up for the starter kit and get access to the UI that Huria is getting ready to show you. So do yourself a favor, rather than trying to run it locally, go to the event page, get the blockchain landing page link, go there and get yourself your own starter kit so that you can use the cloud-based UI as well. All right, back to you, Huria.
Awesome. So that'll basically take us right into the demo. So at this point, I want to show you the IBM Blockchain Platform, and I want to show you exactly kind of what it can do, and show you how I've worked with a roasting company to put their supply chain documents on the blockchain. So let me jump out of the slides here, and I'll go ahead and go into my project here. So as you can see here on the landing page, we have the blockchain bean. So if you go to ibm.com/blockchain bean, it should redirect you to this page right here. And I believe the link should be in the description as well. So really what this project was, as you can see, it was a collaboration with Brooklyn Roasting Company. The main idea behind this project was to show the transparency from farm to cup. So Brooklyn Roasting Company their mission is to serve this sustainable and ethically produced coffee. And, maybe that sounds easy, but it's not easy to prove to your customers that your coffee beans are fair trade and that they are organic and that they're coming from Ethiopia or these really great coffee co-ops. So what Brooklyn Roasting did is they wanted to put all their supply chain documents out in the open for everybody to see, to prove to their customers that they are, in fact, getting ethically sourced coffee and they're getting a fair trade coffee as well. So what exactly happened is we had 4 different participants in our network. So I'm going to talk a little bit about each of the different participants, but you can think about in a typical supply chain, you'll have many different participants. You'll have maybe the shipper, you'll have the grower, you'll have maybe some regulation authority like the FDA or the International Coffee Association that will actually validate your products. And then you'll have the retailer that will actually be selling these end products. So what we did is we have a little story associated with each of these participants. So first, in our journey on July 21st, 2017, we have 150 bags of Yirgacheffe coffee, and they sell at a fair price. And as we continue through the journey, you'll see that the coffee, once it's been taken from the growers, it'll be exported. But first, let's go ahead and view the blockchain here. So if I click on this button, we'll see some of the information that is stored on the blockchain, and you'll see it in JSON format, JavaScript object notation. And you'll see here a couple of the investments amounts here. So if you can read my screen, you'll be able to see that there's an investment for $30,000, for $43,000, and $34,000. And if you look at the title of the investments, it's for food security, road infrastructure, and school classroom edition. So at this point, you may be thinking, okay, you're just showing me this data, but where is the data coming from? So if you go ahead and click on view the original document here, you'll be taken to the industry standard documents that prove fair trade for Brooklyn roasting. So if you look on the right-hand side, let me zoom in a little bit. On the right-hand side, you can see these different investments that I had recently mentioned. So if you look at this school classroom edition investment, you can see the $30,000. The road infrastructure, we have the $43,000, and the food security, we have the $34,000. So what we did is that we took some of these some of this data off the PDF, and we input it into the blockchain and backed it with this cryptographic signing. So again, this is where we got this data, and essentially what's happening here is we had a front end team that worked on putting this together, and essentially they called my REST API in the back end, which let me show you that here. We'll have our submit fair trade data. If I do a GET request right now, I should get that same data back. So exactly the same things that you saw earlier, school classroom edition, road infrastructure, food security, this data is coming from my REST API endpoint that I have up. Sorry about that. There we go. So that's exactly where this data is coming from. This is just the front end that's calling that. So the second part of the story is getting these beans shipped from Ethiopia back to the United States, where they will be sold to the retailer. So on September 19th, about a couple months later, we'll actually be preparing to ship these beans across the ocean. So we can go ahead and view the blockchain. And at this point, we have a packing list. So you see this PL, bill of landing number. PL stands for packing list here. So we'll have more information about the container number, what lot it was in, the invoice number, what vessel name it had, Northern Magnum for ours. We have the seal number, and then we have the actual timestamp, of course. So we'll have all of this data, again, is coming from the original document. So if you click on that link there, you'll be able to see this document. And you'll see that we are getting this data exactly from this document, but you see here that the container number is redacted, or you'll see that it's blocked off here, and that's just for security purposes. That's one thing we were not able to share, and we had to keep confidential. But everything else you'll be able to see here is out in the open, and you'll be able to see exactly what the weight of the cargo ship. You'll get to see a lot of, you'll see that the seal is on here as well. You'll see the timestamp. You'll have the bill of landing number. So you have a lot of details here as well. So just to kind of give a little bit background on this project, the blockchain bean, this was a proof of concept with Brooklyn roasting. And if I had a little bit more time to work on it, and actually one of the things that I do want to work on in the future is to really automate this, process of scanning these supply chain documents. So essentially what I want to do in the future is to have a text recognition scanner that will be able to scan these PDFs and kind of input and automatically be able to populate my blockchain just by scanning the PDFs. So that's a feature I'm working on right now. Hopefully it'll be out in, I don't want to put a timeline on it, but hopefully within a couple months it should be out there and working. But that, there's a lot of places where you can automate this, and eventually you will want to have everything automated to make sure everything's as efficient as possible. But that's one place that I think is really interesting and a great opportunity here. So after a couple weeks on the ocean, we reached the port. I believe this is in New Jersey here, and we have the coffee being imported by Royal Coffee now. So again, we can see the blockchain here, and we have some information such as if there's insect activity, the condition of the container, was there holes, was there condensation in the container, how many bags of coffee were expected, if there's any marks. So we can see the original document here as well. And so another thing you may notice if you're watching this at home is that not all of these data points are actually on the blockchain. So if you look from this specific sheet, you'll see that we have marks, we have bags expected, we have the date that was stripped, the condensation, the holes in the container, the insect activity, and we have some of the weight, but we don't have exactly, we don't have the weights of the individual bags. We don't have some of this other information. So one of the things that you want to keep in mind in terms of a blockchain network is that when someone enters the network and when a peer is entering the network, they're going to have to download all of the data that has previously been stored on the network to be able to sync and to get to consensus. So that means if there's already a very large network and you're entering in in the middle of this network, you're going to have to download like gigabytes of data. So for example, if you're downloading the Ethereum blockchain, that's going to be like 100 gigabytes of data if you want to jump in now, right? And that's a huge expense for your computer. So you want to keep in mind that you only want to actually put the most important data on the blockchain that is really essential. Everything else that doesn't need to go through consensus, that doesn't need that's not as valuable to the business, you can keep an external database, or you can keep somewhere else where it doesn't have to go through the consensus, through all the peers, and that's something that's really important in terms of the design, is to really, and again, one thing that is recommended is that you take something like a SHA-256 hashing algorithm, and that you input all of your data. So whether that's a PDF, whether that's any sort of data, you want to input through this hashing algorithm, and then you only want to store that hash onto the blockchain. And then you want to have some sort of object storage or something, other service in the background having a pointer to those documents. So that's also something designed to keep in mind, because right now I'm showing you these actual documents, but of course, you'd want to keep these off-chain. Like, we don't have these documents on-chain. We have just some of the most important data points on the actual blockchain. And then this document that you're seeing here is kind of external.
So, but just to make sure I understand that, so on the blockchain, you might have a pointer or a reference or a URL for the PDF file, and you would have the SHA-256 hash on the blockchain. So those things can't be modified or changed, and you can use that information to actually fetch the PDF and then verify its authenticity with the 256 hash.
Exactly. So once you pass that PDF through the 256 hash, you'll get this specific hashing algorithm, and only this specific PDF can get that output. Right. So if you modify any sort of information on the PDF, the actual, the PDF, the structure of the PDF will change a little bit. So then once you input that PDF through the hashing algorithm, the output will be completely different. So You'll see that it doesn't match. So that's exactly right. You'll have some sort of output from that hashing function, and then you'll have a link to the actual PDF, but you won't want to store the big file on the blockchain.
Gotcha.
Okay, so again, this data is coming from that REST API that I showed you earlier. Let me show you this one as well. So this endpoint is called submit inbound weight tally. We'll do a GET request on this endpoint, and we'll see how the UI is interacting with the network. So you can see here, this is kind of where this is coming from. So the last thing I want to show you is one more endpoint. And so the last endpoint here that we have is we actually have the Brooklyn Roasting Company. A few months after, this is actually 5 or 6 months after the coffee has been imported to Royal Coffee, Brooklyn Roasting will actually buy these big coffee batches from Royal Coffee, and they're going to grade these sample roasts of the beans, and they're going to critique them. So at this point, you'll see something that's called this cupping method, and this is something I had never known about up until I had worked with this company. I didn't know that roasting companies will actually do something like this, where they, they quantify and they critique all the different flavors, the aftertaste, the acidity of the coffee. So this is pretty cool stuff. You can kind of imagine them kind of sitting in a circle and like sipping and, I don't know, reading a book or something. So kind of cool stuff. So exactly what happens is that they have these, I believe, 8 or 9 different properties that they critique. So they critique the acidity of the coffee, the aftertaste, they have the aroma, the body of the coffee, the flavor, and then at the end of the critiquing process, they'll give it a final score. So all of these attributes are given a 1 to 10 score on a scale of 1 to 10, and then they add up all the scores and they give it a final score. So for this particular batch, if we look at the original document here, you can see that Brian is the one that signed off on this, and he gave this coffee overall 89 out of 100, which is a pretty great score. So you can see it has mostly 9s and 8, 9, and 10s. So you can see it got a pretty great critique. So you see the general commenter, it has a blueberry, toffee, praline, and lime flavor. It has a light body, and it has a slight lingering finish. So pretty interesting stuff there. So what I've shown you right now, all of these different REST API endpoints, all of these have been logged on the IBM Blockchain Cloud service. So right now you can see the IBM Blockchain starter plan if you see my screen here, and you can see I have in this top left corner I have the Blockchain Bean demo, and if you look here, I have multiple other networks. So a pretty interesting and cool feature of IBM Blockchain Starter Plan is that you can create multiple networks and have a really nice way to switch in between them and check out the different data between all of your networks. So right here, you can see my total blocks on the network. I have 766 blocks, and you can see that the time since the last transaction. So this 1 minute reflects when I demoed out I tested out my network right before this. So if I refresh this, hopefully the demo gods are smiling on me today. I'm hoping.
I got my fingers crossed.
Yeah, right. I have a recording, so if worst comes to worst, we got the recording. But I'm hoping to get the live demo. So, anyways, if you look here in my cloud service, so let me back up just a little bit. If we go back to the overview page, you'll see that what we talked about earlier in the slides, we talked about the orderer. We talked about the orderer, which you can see here, and you can see the status as running. Let me zoom in a little bit too, so you can read that a little better. We have the CA, which stands for the certificate authority. We can see it as running here. And then we have actions such as like the view the logs, and this is really useful for debugging purposes as well. And lastly, we have the peer too. So this is where you actually run the smart contract. So if I were to go through a normal workflow right now, let me just show you kind of what would happen. So essentially, I would write my smart contract. I would have it in let me show you a sample smart contract I've been working on. So this is the contract for the bean code. So you can see, let me show you add coffee. This is not too bad. So this function add coffee here, you can see that we have size, we have the roast, and we have the grower ID. So essentially, we're going to give a random batch ID to the coffee. We're going to set the size, set the roast, say that it's ready for distribution, and then we're going to assign the owner to that grower ID. And then this is the API that we call to actually update the ledger, is this put state API. So I'm just showing you just a sample function of my smart contract. So I have several other functions. I have the submit fair trade data that I showed you earlier. I have the submit packing list, which goes into the vessel voyage number, the container number, the seal number. This is all what I showed you earlier. And essentially, once you have everything written and worked out in your smart contract, you'll go to your IBM Blockchain Platform, and you'll click on this install code button at the bottom. And at this point, you actually have to install the smart contract on the peer. So remember, I told you that the peer is the main working horse, or it's the main actor in the network. So the reason that it's the main actor is that it's running the smart contract. So if something goes wrong and there's an error in the smart contract, or something, the transaction is invalid, the peer is going to be the one that says, no, we can't put this data on the blockchain, or we can't update the blockchain because the smart contract errored out, right? So as you can see here, we have our peers, so we can choose a peer. You'll choose org1 peer 1, and then you'll click install chain code. And at this point, you'll choose your files here. So if I go into my work directory as before, I have the bean code, and then I have my contract.js. So I just click this, and then I click on node, and then I'll submit that. So I'm not going to go through this process right now, since we're kind of running short on time, and I want to show you other things. But this is how you actually go through the process of installing your smart contracts and having them running. So at this point, I have all of my contracts installed, as you could see previously, and I have my default channel here. And in my channel, this is where all the transactions are submitted. And essentially what I've been doing is I've been, here we go. I've been submitting these REST APIs to the blockchain network. And each time I submit the request, if it passes through the smart contract, it will increase the total number of blocks. So let's go ahead and let me show you a sample transaction now. So what essentially happened on this blockchain network is we had about a month and a half to build this network out, and I believe it was late July of last year, we demoed out the network at a big food festival. So we had a couple baristas there. We had a bunch of cups of coffee, and on each cup of coffee it had a unique barcode on it, and that barcode actually had a link to my Pour Cup API. So it had a link to this API. And each time we had a different a scanner app that would scan that barcode, and it would actually go ahead and connect to my API endpoint. So each time the cup was scanned, that signaled a transaction on the blockchain network saying that, look, we've just sold this cup of coffee to this customer, and at this exact time period, at this timestamp, this was the barista that scanned it. This is the type of coffee they got, whether it's iced coffee, nitro coffee, whether it's a cold brew. And then it had the details of the beans as well. So where exactly the beans come from. And then after that, the user could go home and put in this cup ID to view the blockchain and to see the history of the beans once they got home, which is pretty cool.
All the way back to the grower.
Exactly.
That's amazing.
So let me show you that in action right now. So right now I have this Pour Cup API, and this API is connected to my blockchain bean starter plan. So once I actually submit a request to this API, I should see this block being added. So it should be 767 blocks if everything goes to plan. So let's go ahead and try it out. Calvin, do you have a random 5-digit number I could bother you for?
Sure. It's 43 16 5.
Okay, let's add one more in there. One more number.
6.
Okay, just to make sure. So I've done this before where someone picked a number that was already in the database, and then I'm not allowed to put the same cup ID in there. So I just wanted to make sure here. So we got NJB 43 16 56. So if we go ahead and submit that, let's try it out. in a couple seconds here, if we refresh this, we should see this 46, 16, 60. I think it's 56 should be reflected on there. Awesome. So we see the block is increased here. We see the time since the last transaction was 11 seconds. And if we actually go ahead and click on this transaction or on this block number, we can see the type of transaction. So it was a function invocation. We can see the chain code. So the chain code or the smart contract was the coffee tracker. And then we have this UUID. And then if we click the details, we'll actually be able to go and see more details. So we'll see that pour cup was called here. And then we can see that cup ID here that I passed through my API, which was 431656. And then you'll have other additional info. If you kind of look back into you'll see a JSON of exactly what's actually being written onto the blockchain. So you'll see here that on the blockchain, you're writing down the cup ID, you're writing down the drink type, which is Nitro, the barista, which is Josh, and you have the timestamp, and you have a lot of other information that maybe is not super useful right now, but there's a lot of information with this transaction.
So this got written onto the block at the time I bought the cup of coffee. Exactly.
Yep. So now, let's pretend I was a customer that went to the event. So I have this cup ID here, and I'm pretending like it's on my physical cup. I don't have
right.
So this was actually the blockchain bean mug we got, which is pretty cool. So let me show you this now. So if you go to the top of this page, you can see this visit us at Smorgasburg. So this was the food festival. So here it shows that you can enter your drink's unique cup ID to view your coffee's journey. So if we go to this page, we can go ahead and enter in that cup ID, what we just entered a few minutes ago. So it's that NJB 431656. If we hit submit, we should see the timestamp being right now. So Tuesday, 8:53 a.m. That's the local time in San Francisco right now. And then you'll see that cup ID, of course, what type of drink it was. So the way that I had submitted this request, it came out to be a Nitro drink. You can see that J in the cup ID. That J is referring to Josh as the barista, and then this B is representing the type of beans, which was the Ethiopian natural yogurt cafe beans. So not only you have this nice kind of details of your cup of coffee, but from there you have this timeline of, okay, I have my coffee came from these type of beans, the Ethiopian beans, but where did those beans come from, and what dates, where did those beans originate from, who actually grew the beans. So you have this nice timeline from January 8 when you got to the coffee to when the coffee was actually evaluated. You can see that right here, when the coffee was actually imported, and you have all this nice information about the shipper, and then once the coffee was actually exported. So you have this really nice timeline to kind of go with your actual coffee too.
That's amazing.
So this was a really awesome project. So I do want to. So what my plan is right now. So I do want to automate this and have some sort of like visual, optical, or character recognition so that I can automatically scan these PDFs and extract that data and kind of automatically call these APIs. But so far, this was just a proof of concept, so we didn't have that much time to automate things. But this is kind of what we came up with. So it was pretty. Yep.
Let me ask a couple of questions because I know this will be out in the audience. It's everybody's favorite topic. What languages do you support, or does Hyperledger support writing smart contracts in?
Sure. So I think that's also another pretty great feature of Hyperledger is that it has multiple languages that it supports. So right now, the contract that I wrote was in JavaScript and node.js, but they do have a Java SDK. I believe I know they support Golang as well, so they support Go. I believe Python is in the works. It's not as developed as the JavaScript and Node.js SDK, but it does have they're coming out with multiple language support. So right now, JavaScript is the most mature, and then Java is very mature as well.
There's a roadmap for additional in the future, which I think is another awesome aspect of Hyperledger.
Exactly. And just a quick point too. If you think about the Ethereum platform, the only way to write smart contracts with Ethereum is with Solidity, right? So you have to learn this new programming language to work with Solidity. Whereas with Hyperledger, you can work with some of the most popular programming languages in the world, and you don't have to learn anything new. You just have to understand the concepts of a blockchain. But you don't have to learn new programming languages.
Right. Okay, thanks.
So I have a couple last slides on additional use cases, because I've gotten these questions in the past on my talks is, you showed me the supply chain use case, but what other use cases can blockchain be applied to? So I want to end with that, with just a couple more slides there. Okay, so one really awesome use case that I've seen. So let me go ahead and play this slideshow. Another great use case that I've seen is keeping track of medical records on the blockchain. So if you think about it, you may have several different doctors that you go to. Maybe you have your primary care physician. Maybe you've gone to a gastro. Maybe you've gone to the dentist. Maybe you've gone to all these different, more specialized doctors. But a big problem is that there's a lack of communication between these doctors. So one doctor won't know your full or it's hard for them to piece together your full patient history, and it takes a really long time to send all these documents through the mail and to the different doctors that need them. So what if you could have your full medical history on the blockchain, so that it's in one place and there's no way to tamper with it, and it'll be a lot easier to really access. So this is what this company called Medical Chain is tackling. So they've created a blockchain solution for the medical industry, and that's been a pretty interesting use case in my perspective. I'm very interested in healthcare and super interested in that industry in general, and I think blockchain has a great opportunity for that industry as well. Another industry that I think is really great for blockchain is digital identity. So if you think about all of the fraud that's happening in terms of stealing identity, and whether that's credit card, identity fraud, I really think that blockchain can solve this by keeping all of, instead of having a physical passport or a physical identification card that you can lose or you can steal, instead of that, having something on the blockchain and having a sort of digital identity on the blockchain, and having one place where all these identities are kept. I think that could really improve a lot of things. And I know that Hyperledger is working on a project, Indy, that is tackling this digital identity problem. And I'm really excited to see what comes out of that space. And one quick thing to note here is that I've heard that's pretty great is, for example, when you go to the let's say, for example, you want to go to a bar to grab a drink, they're going to ask you for your your driver's license to verify that you're 21. So on your driver's license, you have your address, you have your age, you have your weight, what your eye color, I believe. So there's all this extra information that doesn't need to be shown to the person at the bar. They just need to check if you're 21. So imagine if you had some sort of app on your smartphone that just has a checkbox that's verified by the DMV that says, okay, this person is 21. You don't need to show the address. You don't need to show the exact age. You don't need to show the weight, all those other details that are on the driver's license. You don't need to show those details. So I think digital identity is really awesome in that it can, instead of, it can provide the right amount of information to people that need it. So I think this is also a great use case that I'm super excited about. And lastly, one other interesting use case that might be a little bit more niche is in terms of concert tickets. So I know True Tickets is a company that is using the Hyperledger platform to fight this, or to to find these inefficiencies in the concert in the music industry, where there's many people buying tickets and then selling them, outside the door for a higher price, or selling fake tickets, or there's a lot of controversy there in actually in selling those tickets. So what True Tickets wants to do is it wants to actually connect with the artist and have a way for the artist to set the price, and for the consumers to be a little bit closer to the artist and be able to buy directly off the blockchain through the artist, and be able to verify on the blockchain that yes, this is a valid ticket. There's no possibility that this is invalid, and that's another really cool use case that I know is being worked on, and this is an interesting startup there. Okay, so that's more or less it. I'm not going to go through these last slides, but I think we already have the blockchain starter kit in the link there. And then the last thing I believe we have these links there as well. And then here's my contact information if you need it. You can find me this is my email. I've talked about my Twitter handle here, and I have my site, my personal site with has some of my YouTube videos that I show programming with Hyperledger and smart contracts, and my Medium is my blog here. So thanks so much for listening here, and for hopefully you learned something about Hyperledger. So hopefully you feel a little bit better, just like Dwight feels here. And that's pretty much it for today. So thank you so much.